The placement of hydrogen in the periodic system is probably the most discussed topic in the foundations of the periodic table, and the source of much debate among theoretical chemists, chemical educators, philosophers of chemistry, physicists, and amateur scientists. Since a long time ago, there exist disagreements as to exactly which family of elements should hydrogen be included in. Several attempts have recently been made to point to the proper place for hydrogen in the periodic table of the elements. Before we start exploring this topic, let's see what the periodic table is exactly. The periodic table, also known as the periodic table of the elements, is an ordered arrangement of the chemical elements into rows and columns. In the periodic table, the horizontal rows are called periods, with metals in the extreme left and non-metals on the right. The vertical columns, called groups, consist of elements with similar chemical properties. The periodic table provides information about the atomic structure of the elements and the chemical similarities or dissimilarities between them. Scientists use the table to study chemicals and design experiments. The periodic table continues to evolve with the progress of science. Some scientific discussion also continues regarding whether some elements are correctly positioned in today's table. Many alternative representations of the periodic law exist, and there is some discussion as to whether there is an optimal form. Now, regarding hydrogen, it is generally accepted that, in the standard periodic table, it falls into alkali metals because of its outer shell configuration or valence. It is placed in the conventional periodic table according to two different criteria. The first is the chemical and physical properties, and the second one is the quantum mechanical criterion. According to the first criterion, hydrogen is the most difficult element to place due to its unusual chemical behavior. Although it is a light gas at room pressure, hydrogen usually heads the alkali metals sometimes, carrying a slightly different color according to its one valence electron, and because it is an electropositive element that loses its electron readily. But hydrogen is also a good candidate to be grouped with the halogens. Some researchers support its inclusion therein by pointing out the similarities between their chemical and physical properties, and by stressing that hydrogen can form hydride anions. In contrast, Ronald Rich considers the resemblance to halogens real but weak, because the halide ions are stable in water, but the hydride ion is not. In turn, J.W. Van Spronsen claimed that the alkali group seems a proper place for hydrogen, because it forms a unipositive ion and halides. But there is a disparity between alkali hydrides and halides. The unique behavior of hydrogen also makes it resemble to the carbon family. Marshall Cronin has defended this perspective on the grounds of correlation among relevant physical properties, such as ionization potential, electron affinity, and electronegativity. However, as it is well known, carbon is tetravalent, but hydrogen is monovalent, and the boiling and melting points of hydrogen are very lower than those of the elements of group 14. Let's examine the secondary classifications involved in this discussion. Electronic configurations, electronegativity, and triads of atomic number. The quantum mechanical criterion, that is the use of orbitals and electronic configurations, appears to be the modern approach to explain chemical periodicity. According to this standpoint, the number of valence electrons seems to govern the chemical behavior of the elements. This implies that hydrogen is a member of alkali, but according to its electronic structure, hydrogen might be placed at the top of carbon group since its valence shell is half filled like the elements of that group, while also among the halogens since one electron to complete their valence shell is required. Although not as usual as a classificatory criterion, electronegativity has had a revival in the last years. Based on the electronegativity, hydrogen has been placed between boron and carbon, and between alkali metals and halogens. The difficulty to place mainly hydrogen but also helium in appropriate groups has led to some researchers to appeal to other kinds of solutions. For example, it has been suggested that hydrogen and helium should be put out of the periodic table in an isolated group unrelated to alkali metals, halogens, or to the noble gases family. At the same time, the idea of duplicating the positions of both elements, or even triplicate the placement of hydrogen above alkali, halogens, and carbon columns have also been suggested. Criticism might be posed to this last solution, one suggested by Scarry, who claims that this goes against the basic principle of the modern periodic table: one element, one place. As we have seen, this element seemed to resist any attempt of assigning a specific position in some particular family of elements. Even though there are several criteria proposed to decide its positions in the periodic system, it seems that no single place appears to be satisfactory. The proper placement of it is an ongoing question at the core of the periodic system. So what's your thoughts regarding this topic? Let us know in the comments.